Hi everyone, so for today's video, we will be doing our final project in Digital Electronics Laboratory.
For this video, we are to choose from 3 different problems and we chose problem number 2, which is a chemical plant needs an alarm system to warn of critical conditions in one of its chemical tanks. The tank has 4 high-low switches that monitor temperature, pressure, fluid level, and weight. Using your knowledge in switching theory and logic design and construct a circuit that will sound the buzzer for a period of 30 seconds if any of the following conditions used. A. High fluid level with high temperature and high pressure. B. Low fluid level with high temperature and high weight. C. Low fluid level with low temperature and high pressure. And D. Low fluid level with low weight and high temperature. Using K-map to simplify the given condition mentioned above.
This is a truth table constructed from the given conditions of a chosen problem. Using this table, we have solved the logical expressions using Boolean laws and algebra, and finally arrive at the most simplified Boolean expression as was shown in the screen. You can see here that we use another technique, which is the K-map, to simplify Boolean expressions. And it can be observed that we have arrived with the same expression as the ones we have performed using the truth table and Boolean laws. Having obtained the simplified logical expression, we can now decide on the type and the number of gates required to realize the expected logic for every output bit, which further results in the complete design of the desired system.
In here, you can see our designed and builded circuit which represents the microprocessor alarm system for the chemical plant. It is composed of one 7404 NOT gate, three 7408 AND gates, and one triple input 4075 OR gate. For the inputs, we made use of switches which will represent the highs and lows of the conditions such as the temperature, pressure, and fluid level. By having it closed, it represents a value of 1 for that specific condition. Having it open, on the other hand, would represent a value of 0. It can also be seen that the weight condition has been removed in the input part of the circuit for the reason that it was not seen as a contributing factor to the alarm, that whether or not it has a value of 1 or 0, the output would remain the same. This can be further seen on the truth table, K-map, and its respective derived Boolean equations. Looking at the output, we placed a probe component along with the buzzer which would serve as the alarm. If the conditions are met, the probe will light up and the buzzer would make a noise. Now, let us proceed with the experiment. If all the conditions are said to be low, an output of 0 can be observed. If only the fluid level is high, having the temperature and the pressure low, the alarm would still not turn on. If only the pressure condition is high, having the others low, the alarm will turn on. If both pressure and fluid level have values of 1, the result would still be a value of 0. If only the temperature condition has a value of 1, the output will be a value of 1. If both the temperature and the fluid level conditions are high, the alarm would remain turned off. If the temperature and the pressure are high in terms of its conditions, the alarm will be turned on. And lastly, if all the conditions have values of 1, the output will also have a value of 1.
The materials we use for the actual circuit is 5 volts power supply, SPST switch, 7404 inverter, 4075 triple input OR gate, 360 ohm resistor, LED, 5 volts passive buzzer, and breadboard.
K-map simplification process is an effective reduction technique when dealing with logical expressions which contain around 3 to 6 input variables. This technique is simpler and less error-prone compared to the method of solving the logical expressions using Boolean laws. Basic logic gates were once again used in this project, including the 2-input AND gate, 3-input OR gate, and an inverter. With the proper design, these logic gates are essential to operate an alarm system and satisfy the conditions given. From our design, the effect of weight was neglected as it does not affect the output of the system.
So that's it for this video. Thank you for watching.